Hi class, in this lecture we're going to talk about chemical bonding. Okay, so you may remember when we did our lecture on ions, we ended that lecture talking about how atoms like to have the outer electron shell full, right? That's going to make a happy atom. Okay, so there are different ways of getting this outer shell full. What we saw so far with ions is getting rid of an electron or two. That could make the outer shell full, because in the sodium example, we got rid of one electron. It got rid of an entire shell, and the outer shell, which was the second one then, was full of electrons. Okay, so this chemical bonding idea is again all about how do we get outer electron shells to be full. Okay, so I'm going to tell you a few, two of the major kinds of chemical bonds that we have here. So we have what are called ionic bonds. Okay, and this is when ions are attracted to each other. Right, so we talked about ions, they're charged, right? So plus likes minus, minus likes plus. They have that physical attraction, charged attraction for each other. So remember, we have, I'm not going to draw all the atoms here, but remember we had sodium that kicked off an electron, right, which made it Na plus. Well, when we kick off an electron like that, we don't really want it just hanging out on its own somewhere. We want to put it somewhere. And it just so happens that we have some atoms that have space for one electron in their outer shell. So something like chlorine can take this electron and pick it up, which would make this a negative ion, Cl minus. Right? So one atom loses, a different atom gains. What loses is positive, what gains is negative, and then these two things have an attraction for each other. Right? And that attraction, what's holding them together, so in this case, this line that I've drawn here is an ionic bond. Okay? And it creates a chemical compound. It creates this. Right? This is sodium chloride. We know this, right? It's table salt, sodium chloride. The sodium and the chlorine held together in this ionic bond create a sodium chloride molecule, which is neutral. The whole molecule is neutral. We got one plus and one minus when they're together. Okay, it's the ionic bonding that's holding those things together. Okay, and then we also have what are called covalent bonds. Now notice in our ionic bonds, the electrons are actually lost and gained. And those are forever. You can't go back. Like sodium can't get rid of an electron and then say, oh, just kidding, want it back. It can't do that. If it gives up the electron, it's always missing that electron. It's always going to be a sodium ion then. In these covalent bonds, what we see is that atoms are actually going to be sharing electrons. And this is reversible. Like if I'm sharing something with you, when we split, I get to take that home with me because it's mine. And that's the way these electrons behave around these atoms. They share the electrons. Whichever atom the electron belongs to, it goes with that atom if this splits up. Okay, so sharing electrons, if it's covalent. And then there's a couple of options here. We can have equal sharing, or we can have unequal sharing. Right, so for the sharing idea here, just think of circles like this, and this is not going to be perfect drawing it by hand, but if these were the same size and we have this electron that's doing this figure eight around these two circles, it's going to spend the same amount of time around each of those, equal sharing. But now if we have an atom that's really big and one that's really small, then the electron's going to spend much more time around this big atom, much less time around the small one. That's unequal sharing. Okay, if it's equal sharing, we call it nonpolar. If it's unequal sharing, we call it polar. Okay, so think about things that have poles, and what's that mean, right? So maybe like here's the Earth, equator, North Pole, South Pole. It's the opposite ends, right? Like opposite ends of something. A car battery, right? You've got a positive end and a negative end, right? The battery you put in your remote, positive end, negative end, right? So poles are just opposite ends of something. And in this case, it's the opposite ends where these atoms are sharing electrons. And remember, electrons are negative. So that's going to mean that this big atom here is going to be more negative because the electron's there more. And this small one's going to be positive because the electron is there less. Right? So that's unequal versus equal sharing with covalent bonding. So those are major kinds of chemical bonds that we have. There are others. I'm sure we'll see one here and there that's not ionic or covalent, but these are the big two categories.